we're ready now for Module 8, which is about using MATLAB to make professional-looking graphs. So let's dive into that. MATLAB's popular, is extremely popular, and one reason is because, as we've talked about, it's array-oriented, which makes plotting things easy. Of course, there's an extensive help command. We've talked about that, and the doc. So there's lots of help. There's lots of videos because it's used so often. To plot with MATLAB, there's several ways. We'll look at a couple. You run the plot arrays, plot data. It's called the plot command. There's also a quick plot. If you have a function form and you want to plot it like you would on any plotting software, there's one called fplot. We've dealt with CLC and clear. When you make a plot, it comes up in its own window. You can clear that window, which is a CLF, which works like a CLC, which clears your command window, and that one clears your plot window. All right, so suppose I wanted to plot this line. This is something that actually changed in this version. So if you were using an earlier version, and I'm not sure which version it changed in, but I think in 18 this still worked. Then you would plot it like this. You do fplot. You put between quotes your function using regular MATLAB for multiply and add, and then you put the range over which you want to plot it. Now MATLAB is changing how it does graphs, and so what it prefers is this at x, which means it means what follows is a function of x. It's called a handle. So that instead of the quotes, and then we have the same function with no quotes, and then we have the same 0 to 60. You can see in my graph here, I got a nice straight line that basically goes from 0 to 60. If you plug in those numbers, then you just get a nice graph like that. We won't use that one very often, but it is there for you if you'd like to use it. Then we have other functions. Actually, the plot window is now more interactive, and you can go add these things to it after you've created the plot. But if you want to do them inside your script file, then we have these different functions. One's called title, and whatever's in quotes goes on the first line of the title. You've got an X label and a Y label. Whatever's in quotes goes in the style that science folks use, which is rotated. Notice here I put density. I actually was able to use the Greek symbol because I did a slash, and when I put the little up arrow, it recognized that and made it a cube. And then I can put a grid on my plot. So that's how I sort of fancied up the one that we just had, right? Theoretical line. I put X and Y labels for what those things stand for. This one would have been, say, mass versus density. All right, this is going to end up being your PA18, that we'll modify it some. And so this is exactly what I just said. You can you can do this from command window, or you can put it in a script. We've talked about script files, so I'd recommend you put it in a script rather than typing it in, on the command line, which if you mess something up, then you got to retype everything for the most part. So do that for your PA18. Create your file, put your header, open your header file, save it, describe your input variable X, your output variable Y. All right, you might want to pause it while you do that. Now, once you get your plot up, it's in what we call a plot window, and so that would appear in a window of its own with things across the top that you can do to it, a number of functions that you can do to it, and then one of them is you can save it, but we have to be a little bit careful. Just the straight up and down save is going to save it as a MATLAB program. That's basically a bitmap. We don't want to do that. So when you do a save as, make sure that you pick either a JPEG or a PDF. If you're going to ship it to me, just send, if you're going to turn it in, please do it as a PDF. If you're going to put it in a report, like when we start doing our projects, programming projects which involve a report, then you can save it as a JPEG, and then you can include it. You include PDFs, but it works better with JPEGs. You can include it in a Word document before I insert the picture. So, and for like PA18, 19, and 20, you're going to save in plots. That's what you're going to do. You're going to go on here, and like I said, there'll be a save as. just like regular window, and make sure you save it as one of those types. Don't save it as a MATLAB file, MATLAB plot. Now let's talk a little bit about how, making scientific plots. You're all headed into engineering probably, and be making lots of plots. And there are a couple of standard ways of doing it. This is one that I picked that actually comes out of that egr157 book we use. I've seen some others, but this is pretty standard. Of course, we have to put labels on it. I'm going to want your title to be your name, so y'all know whose plot's whose. Put grids. You can put major and minor ticks on the grids. Mainly, if we'll just use our grid command and let it decide. And then axis labels are rotated, and they occur in three pieces. You've got the name of the word for what it is. You've got the symbol how it's going to appear in some equation in your report, in parentheses, and then in square brackets you put the units. Same thing here. So mass, M is the symbol, G is the unit. All right, and all of our graphs are going to look like that, unless it's just an algebraic graph, and then you could just put X and Y of X, or T, and if it doesn't necessarily stand for time, if it doesn't stand for anything physical. But if it's from a physical science type situation, then that's what you're going to use. Some plotting functions are grid, legend, if you have more than one plot on a line. Axis will let you, MATLAB's going to pick do a good job. If you feed it the X's, it'll pick what it wants to be the max and mins, and it does a pretty good job. But there are times when you're going to want to do it yourself, and you do it with an axis command. So if I wanted to force the x-axis to go minus 10 to 10 and y minus 10 to 10 to keep it square, then that's how I would do that with that command. All right, now sometimes we're going to want to plot data. We want to plot points, and we don't want them to appear as lines. We want them to appear as data points, like in a physics lab. And so here's how we're going to do that. You have your data. So here's H1 and P1. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and another plot. And then I'll plot it H1, P1, H1 on the horizontal, P1 on the vertical. And then to make it markers, if you do a help on plot, you'll see there's several of these. But in quotes, I put an O. And for the second one, I put pluses. And if I wanted it to be red pluses, I could put a red plus. Here's where I use my axis to make, since I'm, how it picks will depend probably on which one you feed it first. So what we're going to do is we're going to force it to use this particular range. Then my title, my legend, and my axis. The axis can come before you're actually plotting again. Here I've done it after. Let's see what that gives us. Yeah, so we got blue. Well, actually, I think it changes colors, or maybe I did put an R plus in there. I think if you do more than one, it changes colors. And there's our circles. There's our O's for our first data set, and there's our second data set. And I put a legend. Go back and look how we did the legend. I just put what each one was for. So this was a power versus height. For a motor or something, some kind of measurements we were running for 100 kilograms and 250 kilograms. So I know, so I can put a legend on it. Notice I've done the 3, power, P is my symbol, horsepower, height, H is my symbol. So that's how we go about. Well, notice we've done two things. We put two graphs on one graph plot. You just have to go X, Y, X, Y. But then after it, you can also have all sorts of control. You can do a help on plot to see the various things you can do. You can pick the color of the line. You can pick symbols. I put my title on. Again, to review, I want all of our plots, most of our plots, to be labeled this way. So modify 18 to have both data and a theoretical curve on it. So this would how would we do in a physics lab? You might do a Hooke's law experiment. When I was teaching the physics, we always did a Hooke's law. We'd do a plot. We'd measure, in this case, we'd put some mass on it and measure how far it went. Well, this is something versus density. And so there's the theoretical line. We'll see if that line fits that data. So there's my X data, Y data. Here's my X, Y. done with a linspace, and since I don't tell it anything to do, it'll basically just connect them with short lines. X data, Y data, I want those to be red pluses. There's my legend. That was my line. That's my data, my name, and my axes. Didn't fit the data very well, but you know, at least it stands out. Now what? So I want you to modify your P18 to be like this with the appropriate header, making this graph, and I want your graph to be like this, and I want you to save that graph as a PDF, and then you'll submit me 2 files. Submit me your script and your plot. You don't have to submit me a diary file, since basically nothing's going to happen when you run it except for it make the graph, so submit the graph instead. All right, I'll do another graph, another lecture, and some other things we can do with the plot command. So I'll see you in that one. Bye.